All right, we are looking today at topic 1.1, day 2 of that topic, and we're starting off with the definition of what is a line segment. All right, so remember the things that I highlight are the things that go in the blanks on your notes. All right, so we look at first. I move on over to the segment. A segment is a part of a line. First of all, a segment is a part of a line, and it consists of two endpoints and all of the points that are in between them. So when we look at a line segment, very similar to a line that we talked about yesterday, for the same reason, it has an infinite number of points. That's what it says on your paper right there, okay? So it's just like we talked about yesterday. If this chord right here is a line segment and my hands are the endpoint, if I cut it in half, where the line segment is now that long, and now it's that long. I do it again, it's that long. And eventually, my hands are basically right next to each other, but as long as I'm cutting it in half, I can do that an infinite number of times, and there's still going to be something left inside of there, okay? That's how we know there's an infinite number of points, because it doesn't matter how many times you do that, there's still something left. Under dimensions, there is one dimension, just like lines. Line segments have one dimension, and that is length. And they are named, first of all, look at a diagram. That's a good example of what a line segment looks like right there. Okay, it's got two distinct endpoints in this diagram right here. Those endpoints are A and B, and it is named by its two endpoints. All right, it is named by its endpoints, and just like in a line, it doesn't matter what order you go in. You could call it line segment AB, or you could call it BA. I want to go ahead and draw your attention to the little symbol right here. Okay, yesterday when we talked about lines, we had the two letters A and B, and we drew over the top of it, we drew that arrow, or we drew the line with two arrows, with an arrow on each end. Okay, when you're drawing a segment, it does not have the arrows on top of that line. Okay, it is just the segment line with no arrows on the ends of it when you're doing that symbol right there. All right, so next we move on, we're talking about rays. A ray is also part of a line, and it consists of one endpoint, and it has an infinite number of lines on an infinite number of points on the other side of that end. Okay, so a ray is something that looks more like that. You'll see on this right here, it's got one endpoint A, and everything to that side of it is on the ray. Okay, this point B is on the ray, but A is the endpoint of the ray. All right, when you're naming a ray, unlike when you're naming lines and segments, it does matter which one comes first. Okay, you name a ray first by its endpoint, and then another point that's on there. Okay, so the only option, we could not call this one ray BA. We would have to call it ray AB. That's the only way this one would work, because A is the endpoint and everything else follows after that. That tells us the order of the points, the order of which one you write first, is what tells us what direction the ray is going in. So you can think of it like a ray of sunshine, okay? The endpoint of a ray of sunshine would be the sun right there, okay? And that ray of sunshine goes on and on and on forever. After it starts at that endpoint, starts at the sun, it'll go into space on and on forever until it runs into something. Hopefully, it runs into a planet and makes a nice sunny day. Opposite rays are what happens when you have two rays. Okay, so on your chart on the top left, the number of rays would be 2. Number of endpoints would be 1, because they share the same endpoint. All right, the number of rays would be 2, but the number of endpoints would be 1. We are also looking at opposite rays. They look like this. Okay, what we actually have right here, it looks like just a line with 3 points on it, right? What we have is two opposite rays that have the same they share this endpoint C. We've got one that starts here, ray CA starts there and goes that way, but we also have ray CB that starts there and goes that way. All right, so when we name this ray, when we name opposite rays, you name opposite rays by their shared endpoint, and then any other point that's on each ray. So in that picture right there, we've got CA is one ray, the one that goes to the left, and CB is the one that goes to the right. And that diagram is a fantastic example that could go in the bottom left of your chart. I want to draw your attention to something else though. Let's suppose I had a point right here, and I had one ray that went off to the side like that, and I had one that went up like that. The question is, would those two be opposite rays? And when I've asked this question in class, somebody always says yes, and someone else always says no. Okay, I always get mixed answers on this. And here's what I'm thinking. These two rays, they do have a shared endpoint right there. But when I put them together, they do not form a line. Okay, that is part of this answer right here, is that opposite rays form a line. All right, that's something that goes in the top right of your chart. Opposite rays form a line, and when we talked about lines in the previous lesson, lines are a straight path. Okay, this right up here is not a straight path. So what this is, this would be something to go under non-examples. Okay, the bottom right of that chart, this would be a non-example. Okay, take a look at this picture right here. If we have a common endpoint, the light bulb of this light, if we have a common endpoint, we've got some rays that shoot straight off to the left, some rays that shoot straight off to the right. Opposite rays are the ones that when you put them together, it makes a straight line that goes right across like that. The next page, looking on the back of the page, it starts off with just a couple of quick definitions. Okay, a quick little English lesson. Collinear, the root word of this is line. Okay, whenever you look at that word, you can actually see the word right in the middle. You can see line. Okay, whenever you hear that word linear, it's referring to something that has to do with lines. Okay, so we have that prefix at the beginning, co. You think about your co-workers. Those are people that you work with. People that at your place of work, you are together with them. Okay, so co means together, line, linear means line. So collinear means that points are together on the same line. All right, so points are on, collinear points are on the same line. Okay, this is a good picture of them right here. Collinear points would be P, Q, and R. You've got one line that goes through all of them. Non-collinear points do not have one line that goes through all of them. Okay, those are not all in line with each other, so they are not collinear. Coplanar is very similar. Okay, that root word is one of the other things we talked about in the previous lesson would be plane. Okay, that word, that prefix co means the same as it does in the other word, co meaning together. So coplanar would be on the same plane. Okay, points that are coplanar are on the same plane. Look at this picture. Okay, A, B, and C right here are all coplanar. When we look at this next picture, we've got one that's not on the plane. So all of those points are not coplanar. All right, the next thing would be our postulates. Okay, and postulate is kind of a weird word. All right, postulate is something that comes up in logic. Another word for it is axiom, and what it means, when you look at the left side of that, the left column on your paper, a postulate is an accepted statement of fact. Okay, an accepted statement of fact, or an accepted statement of truth. Okay, a postulate is something that after we say it, after we talk about it here in class, we're going to assume from now on that it is true. Okay, so an accepted statement of fact. So the question on this slide is, how many lines can you draw between these 2 points? That's a pretty good question. Okay, the really obvious one is going to go. The really obvious one is going to go about like that. I didn't do a very good job drawing that on there, but it goes through both of those points. All right, there are a lot of points you could draw. There are a lot of ways you could draw this, right? What about this one? Does that count as drawing a line? What about that? If I do like that, does that count as drawing a line? And the answer is no, it doesn't count, okay? It doesn't count. The only thing that would count would be this straight line right here, okay? As we talked about before, a line is a straight path between 2 points, all right? So that's our first postulate that says if you have 2 points, there is only one line that goes through them, okay? Through any 2 points, there is exactly one line. Okay, so look at that right there. We could have a bunch of different lines that all go through B. We could have one like that, or like that, or like that. We could have a bunch of different lines that go through A. Any of those, they all go through A. But the only one that goes through both of them is this one right here that's already drawn. All right, so draw that picture on your notes right there. Draw that picture on your notes and make sure you understand that the only one that works with the only line that would go through both of those points is that one right there. None of the rest of them could do that. Our next postulate is kind of an obvious one. These 2 lines intersect. It asks the question, where are they intersecting? Well, obviously they meet each other somewhere right about in the middle of there, right? Okay? What we can do is we can label that and we're going to call it point C. That's what our postulate says. When 2 lines intersect each other, they meet at exactly 1 point. They intersect in exactly 1 point. All right, so draw this picture on your paper, and we can say that line AE and line DB, those 2 lines right there, they intersect at this point in the middle, point C. That's what goes in that blank right there. Okay, make sure you're drawing this picture on your notes because it doesn't make any sense to fill in point C if you don't have this picture that goes with it. Our next postulate is a bit more complicated of a picture, so that's why it's already printed on your paper. All right, we've got 2 planes. On the slide here, it's got one red one and one blue one. Okay, you can see that they meet each other sort of in the middle right there. Okay, those 2 planes run into each other, and those 2 planes definitely have this point T and this point S in common. Okay, here's the question. Are S and T the only thing they have in common? Well, I'd ask you, what about right here? They have that point, they have that spot in common, right? What about this one over here? They have that in common. In between there, they have that in common. They have, in fact, all of this, all going up and down right here, all of that is stuff that those 2 planes have in common. What does that form? It forms a line, okay? This postulate says when 2 planes intersect, they intersect in a line. They intersect in exactly 1 line. It'd be even better if I could make the highlighter work. They intersect in exactly 1 line. All right, so in this picture right here, with those 2 planes meet each other on the line ST. Okay, a good way you can think about this is on a building. Okay, 2 planes intersect each other. Well, we know that planes are flat surfaces, just like the walls on a building, right? So when you look at this right here, we've got 1 plane, that's this wall. We've got 1 plane that's this wall, and they meet each other, and what they do is they make this corner of the building, right? Well, that corner isn't just 1 point. That corner is all of the points that go up and down right there. And what that makes is that corner, that edge of the building, that is a straight line going from the ground up, okay? So when two walls meet, when 2 planes meet, 2 flat surfaces meet like that, all of that whole thing is the intersection of those 2 flat planes. So that whole entire corner, that line going straight up and down, is the meeting, the intersection of those 2 things. All right, our last postulate talks about having 3 points, and the thing that's going to go in that blank right there says through 3 non-collinear points. there is exactly one plane. All right, the word non-collinear is what's going to come up on, is what you're going to fill in right there. Non-collinear. All right, look at this. Okay, when I go from this slide to the next slide, I want to show y'all something. It's actually exactly the same thing, okay? Even though these pictures look different going from here to here, this plane P is represented by exactly the same thing as this picture right here, okay? This plane is just whatever flat surface that goes on and on and on forever that has all three of those points on it. All right, so our postulate says through any three non-collinear points, that's our word, non-collinear, there is exactly one plane. All right, so we look at Q and R and T. That's supposed to be T, not S. When we look at those 3 points, they're not all collinear. They're not all on one line. This plane P is the only one that could contain all 3 of those points. It's the plane that's on the same level as this whole entire screen. Okay, if you extended this screen, or if you put this slideshow onto a big giant screen, that screen would be the plane. If you projected it onto a wall, that wall would represent the plane. Okay, whatever flat surface is in line with these 3 points, that's the only plane that could contain all of them. Okay, think about that. What if I took a piece of paper? What if I took a card like this and I tried to, and you can't really see what I'm doing, but if I tried to make the edge of this card meet all 3 of those points, well, I can put a piece of paper on there and I can make that plane run through 2 of the points at a time. I can make it go through R and T, R and Q, or T and Q. But the only way I can make this card be in line with all 3 of those points is if it is exactly the same plane as the screen itself. That's the only possible way that would work. Okay, so what that's saying is there is a unique plane that contains all 3 of those. The last thing we have is these questions right here. What's the difference between a line segment and an array? We talked about it a little bit at the beginning, okay? Think about it. A line segment has 2 endpoints, 1 on each end, right? A ray only has 1 endpoint. A ray, after that endpoint, goes on and on and on in one direction forever. Okay? A segment has a definite length, a definite start and a definite end of it when you draw it on your paper. So this next question, how many points can you find on a ray? Okay, usually on a diagram, there's only 2. Okay, usually there's only 2 of them that are labeled, but you got to remember that rays are like lines. They go on and on and on forever. There's an infinite number of points on a ray. Our last question, 2 planes intersect in a line. Okay, we just talked about that a second ago. When 2 planes meet each other, planes go on and on and on forever. Okay, that's why this says both are infinite. Planes meet each other in a line. And planes are infinite, so the line where they meet is infinite. Okay? The sides of a box, however, are not infinite. And so I direct your attention to this box right here. Okay? The sides of a box are not infinite. If I took the 2 sides of a box, if I took this side, the top of the box, and this side right here, okay? The place where they meet each other is this edge, the edge of the box right here, okay? What is represented by that edge that's in between my 2 fingers right there? When I ask this question, somebody always says endpoints. I said, well, my fingers right there are endpoints. But what is this distance in between them right here? That right there is a line segment, okay? So when 2 planes meet, they make a line, but this side of the box is not an entire plane. It's only a little piece of a plane, okay? This part of the box is an even smaller piece of a plane. So when they meet, they can't form a whole line. They only form a little piece of a line segment. All right, so that's what will go right there, line segment. After that, the summary part, complete one of those statements. That one is on you, and that's all we have for these notes.